So here we have two sets, A and B, and we need to find out which of the following relations are from A to B. Let us begin. Now here we have the set A containing 3 elements, 1, 2, and 3. We have another set B containing 3 elements, 4, 5, and 6. Now, before beginning, let's try to find out the Cartesian product of A and B. So the Cartesian product of A and B, that means what we'll do, we'll consider the first 3 elements of the set A, and we'll find its Cartesian product with the set B containing the elements 4, 5, and 6. Okay, fine. So now what we have the Cartesian product of two sets. We'll start with the first element of set A, which is 1, and we're going to form an ordered pair with each of the 3 elements of B. So 1, 4. Next we have 1, 5, and then we have 1, 6. Followed by we have 2, 4, then we have 2, 5, and next we have 2, 6. Fine. Next we have 3, 4, we have 3, 5, and then we have 3, 6. So this is the Cartesian product of the set A with B. Now coming to the first relation, R1. Now R1 consists of 3 ordered pairs, 1, 4, 1, 5, and 1, 6. Now as we can see here, that all the 3 elements, all the 3 ordered pairs of R1 are also member of the Cartesian product of A and B. So here we can immediately say that R1 is a subset of the Cartesian product of A and B, which simply tells us that R1 is a relation. This is indeed a relation. R1 is a relation from A to B. A to B. So 1 is fine. Let's go to the second one, R2. Now R2 has got 3 ordered pairs. We have 1, 5, 2, 4, and 3, 6. So here we can see 1, 5. Next we have 2, 4, and then we also have 3, 6. That means all the 3 ordered pairs of which belongs to R2 is also a member of the Cartesian product of A and B, meaning R2 is also a subset of the set, the Cartesian product of A and B. So this implies that R2 is a relation from A to B. Fine, let's move on to the third one. Now in the third one, we have the ordered pair 1, 4. Yes, 1, 4 belongs to the Cartesian product of A and B. We have 1, 5 that belongs to it as well. 3, 6. Do we have 3, 6? Yes, we have 3, 6. Then we need 2, 6. Yes, we have 2, 6 as well, and then we have 3, 4. Okay, so all the 5 elements of R3, that means all the 5 ordered pairs of R3 are also member of the Cartesian product of A and B. So here also we can say that R3 is a subset of the Cartesian product of A and B, which means that our relation R3 is indeed a relation from A to B. Fine. Now let's come to the final one, R4. Now we have a problem with the first element itself. The first ordered pair 4, 2, that is not a member of the Cartesian product of A and B. We don't have to now look for the other elements. One of the element is not a member of the Cartesian product of A and B. This simply implies that R4 is not a subset of the Cartesian product of A and B. This simply means that R4 is not a relation. This is not a relation from A to B. So that means of the 4 relation R1, R2, R3, and R4, except for R4, all the remaining 3, R1, R2, and R3 are going to be a relation from A to B. Here's a typo. This is from A to B.